Hey guys, Andy Robertson here with CQE Academy, and I'm super excited about this video today. It's been highly requested, and it's all about root cause and corrective action. I want to go through, that 5-step process to effectively determining the root cause and then creating corrective actions that effectively address the root cause. All right, let's head over to the computer and get started.
All right, let's take a look at today's agenda. So if you're already somewhat familiar with root cause analysis, you might have heard of a bunch of different terms and processes. 8D is a really common term for root cause and corrective action. What I'm showing here, what I'm going to teach today are kind of the 5 general steps of root cause analysis, as well as preventive action. So we're going to go through problem identification, root cause analysis, problem correction, recurrence control, verification, and then prevention or preventive action at the very end. Okay, let's get into this. So when we talk about problem identification, there are 3 really important steps or 3 really important elements of what you should do when a new problem is identified. The first, and this is incredibly important, is to quarantine all potentially affected material. I say potentially affected because at this point, without understanding the root cause, and without understanding and collecting data around the scope of the material, you may not understand or you may not know what the true scope of the problem is. So it's good here to be conservative and identify all potentially affected material and then quarantine that material to prevent mix-ups. We want value to continue flowing through the process. We want to partner with our friends in operations, and we want to make sure that value is allowed to flow, but we also need to mitigate some risk by implementing some interim actions. Now, again, this should all be risk-based, and so as a problem occurs and throughout the entire root cause process, you should be thinking about risk and how do we mitigate risk, and that should play into the interim actions that you take here. Maybe it's 100% inspection, additional sampling. There's all sorts of different interim actions that you can put into place to sort of address this new element of risk that's sort of cropped up in our process. By the way, when we talk about process controls and quarantines, I always love to show this control plan because, as you know, the very last step here in our control plan is what's called a reaction plan. What are we going to do when a problem occurs? And that includes segregating material, dispositioning material, right? There's different elements here of the reaction plan, but we should be clear. We should use our reaction plan in these instances that, hey, if we're taking this measurement and we get a failure, what do we do and how do we react? All of that should be driven by your control plan. By the way, the other thing I love to talk about here when we talk about quarantining potentially affected material is to remind you of the entire value stream. So depending on the failure mode itself and how material flows through our process, we might have affected material at various stages in our value stream. Raw material, WIP, finished goods, goods in transit, goods at the customer. And so it's important now to talk about, hey, where's all of our potentially affected material and what levels of our value stream do we need to look at to make sure we're quarantining all the right material. All right, that was step 1 in kind of problem identification, which is quarantining affected material. Step 2 is all about forming a team. Complex problems always require a team of experts who have different experiences and different expertise and different perspectives to truly help solve a big, hairy problem. So step 2 in problem identification, or the second important element here, is to form a team of experts. Now, again, depending on the risk and the scope and the size of the problem, this could include a handful of different key players on the team. That might include a team champion. Maybe this is a senior leader in your organization. Maybe this is an operations leader or a quality leader who says, "Hey, I'll be ultimately responsible for the results and the timeliness of this investigation." So maybe you have a champion. Or maybe as a quality engineers and continuous improvement professionals, we play the role of a team leader or a team facilitator, which is essentially somebody who can guide the team through this process, right? Help the team use the tools correctly, help the team come to the right solution, and making sure that we're coming up with creative, corrective actions to address problems. Those are the roles that we as quality engineers and as continuous improvement experts often take. And then last, but certainly not least, is the note taker. Your root cause analysis and CAPA process is a critical foundational element of your quality system, and it should be well documented. And so having a note taker who can attend meetings, document action items, take notes, can be a really effective way to both document everything that's going on in your investigation, as well as keep the team on track. And then speaking of the team, right? It's really important as members of the team that we think about the development of the team. Are we forming, storming, norming, or performing? And how does our behavior, impact the performance of the team? Because oftentimes during root cause analysis, things can become difficult, they can become contentious, they can become combative. And so it's really important that we communicate effectively, that we be respectful, and that we make sure the team is as high performing as possible so that we get to root cause and we come up with corrective actions, and that we maintain those positive team dynamics throughout the entire process. And then the last phase of problem identification, this is the third element, is to form a great problem statement. So a good problem statement includes all of the appropriate details surrounding the problem, and this will essentially springboard you into the root cause analysis process. So this is a great opportunity to sit down and use two tools that are really great for forming a problem statement, and that's the is not analysis, along with the 5W2H. So 5W2H is who, what, when, where, why, and the two H's are how and how many. And then the is not analysis is essentially, who is complaining about the problem or who is not complaining about the problem. When did the problem occur and when did it not occur? Where did the problem occur and where did it not occur? Maybe you have multiple pieces of equipment and this nonconformance or this defect is only occurring on one piece of equipment and not on the other pieces of equipment. And it's through this process of talking about what is and what is not can oftentimes reveal really interesting conclusions around the problem that will lead you into root cause analysis. By the way, these two here at the bottom, how many and how bad, are a great way to talk about risk. So the two elements of risk are severity and occurrence. And that's basically how many or how, what's the frequency of occurrence of this defect. And if you ask the question, how bad is it? What you're asking is, what is the impact to the customer? What is the severity of this failure mode? So these last two questions are a great way to capture data around the risk associated with your problem. So here we are, we're at the end of problem identification, and we've done three things. We've quarantined the affected material, we've formed a team, and we've written a specific and clear problem statement, and now we're able to move into the root cause analysis phase of this CAPA process. Okay, so let's talk a little bit about root cause. We're going to talk about some tools. I want to start with some tips. Tip number one is Genchi Genbutsu, and this simply translates to go and see for yourself. Go to the place where the event occurred and see for yourself. I think a lot of people make the mistake of trying to solve problems in a conference room or from their desk, and there's so much value in going to where the problem occurred, whether it's the production floor or the shipping dock or the warehouse or whatever happened. Go and see for yourself. Interview the employees, get to visualize the process and understand it better, and that'll really lead you down the path of root cause. I think that's a really important aspect of solving problems. Tip number two is to focus on the process, not the people. When problems occur, and I think a lot of bad root cause analysis tends to blame people. And I think it's really important as quality engineers and continuous improvement professionals to focus on the process. And then tip number three, and this again goes back to root cause, is make sure you're getting past the symptoms to truly understand the root cause. So now let's talk about some tools that you can use to assess root cause. So I have a whole separate YouTube video on this. Go check it out. It's fantastic. On the 7 QC tools, I think all 7 of those tools can be useful in different aspects of root cause analysis depending on your situation and the type of data you're analyzing. But all 7 of those tools can be incredibly useful to solve problems. I want to highlight 2 of them specifically. The first one is the flow diagram, and I love this from Deming. If you can't describe what you're doing as a process, you don't know what you're doing. This goes back to tip number 2 where I said focus on the process and not the people. And to do that, to really focus on the process, one of the best ways to do that is to create a flow diagram. What are those steps of the process that could contribute to the failure mode? Now, one important thing I think that's really important here is pair this up with Genchi Genbutsu. Go to the place where the problem occurred and talk to the experts who understand that process to create a flow diagram of exactly what that process is. Now, the reason that I love a good flow diagram is it does 2 things. It makes a really complex process simple. It helps you really quickly visualize all of the different steps in the process, which might lead you to, hey, this particular step could fail in a certain way, right? That might cause the problem. But then it also promotes a common understanding of a process. If you're part of a team and you've got individuals from different departments and different groups, it's not uncommon for people to think about the process differently. And that's a great way to kick off a root cause analysis and just ask your subject matter expert, go up to the board, write down the process, let's create a flow diagram, and let's talk about exactly how the process is today. And then tip number 2, and I love this one, this is the cause and effect diagram. I mean, this tool exists purely for root cause. Now, remember what we do is we start with our problem statement over here. We take that problem statement that we generated during problem identification, we put it in here, and then we start brainstorming all of the possible failure modes within these 8 different categories that could cause or contribute to that problem. Now, we can obviously pair that up with some 5 why analysis, and this is probably the most simple and most effective problem-solving tool out there. It's simply just asking why 5 times to make sure that you're getting past those symptoms and truly identifying the root cause. Now, of course, I always put this team down here because remember, this is a team sport. Not any single person is an expert in all 8 of these categories, so you want to get the right people with the right expertise in the room to make sure you're thoroughly investigating all of these possible root cause categories. By the way, there are a ton of other tools that can help us with root cause analysis. One of them happens to be design of experiments. So for example, right, what we might do is we might sit down as a team, brainstorm some factors within our process that might contribute to the problem, and we might create a little full factorial DOE, and what we might look for are things like interaction effects, right? How do these different factors interact? Perhaps there's some weird interaction that we've never quantified before that is somehow contributing to the particular problem. Another aspect of really getting down to the root cause often involves measuring parts. And so it's not uncommon for, as part of the root cause analysis, to create this failure mode, to measure it, to quantify it. And this can obviously help lead to root cause, but it can also help with a risk assessment. So oftentimes during a risk assessment, we have to quantify how severe is the failure mode. And sometimes functional testing can give us some insight as to how bad the problem is. And that testing can also give you insight as to how frequently the problem is occurring. Now, we can't talk about testing without talking about gauge R&R. It's important during the root cause phase to challenge the measurement systems that were used that actually discovered the nonconformance. Perhaps your nonconformance or your issue is related to the measurement system that was used during that inspection. And so think about your gauge R&R. Don't forget about measurement system variation. Perhaps there's something wrong with your measurement system that needs to be investigated. And then, of course, if you're going to be taking measurements, you may as well quantify something like process capability. Oftentimes during root cause analysis, we can essentially re-quantify our capability to see if it matches, what we would expect, or possibly is there some new source of variation that has reduced our capability and it explains all of these defects that we're seeing. And then we can't talk about root cause without talking about a risk assessment. This is a really important element of our quality system, and it should be the basis of your corrective actions, the depth of your investigation, how you quarantine material. Every decision we make should be risk-based. And so as we're going through the root cause analysis process, we should be attempting to quantify those 2 different elements of risk. Remember, risk is a combination of the frequency of occurrence and the severity of a failure mode. So if you're measuring parts or if you're quantifying defects, all of that information should get put back into a risk assessment, because ultimately at the end of the day, remember, all of your corrective actions should be risk-based, and risk should be one of the major driving factors in the depth of your analysis and all sorts of different factors in this particular process. So don't forget about risk. Now, let's move on to what we call problem correction. So let's assume you've done your root cause analysis and you've identified what you believe to be the root cause along with contributing factors. Now what we have to do is essentially brainstorm potential corrective actions. So at this phase in the process, right, we have to come up with potential ideas to essentially address the root cause and the contributing factors. And to me, this is continuous improvement, right? This is where we get better. This is where we improve our process to eliminate defects and eliminate variation and essentially get better every single day. Now, this could be all sorts of different solutions. It could be some sort of mistake proofing element. It could be new inspection or a new control point, or you eliminating some new source of variation. And what's important here is when you come up with that list of potential corrective actions to essentially evaluate and test those potential solutions. So you could use something like a matrix diagram that essentially lists out your various options, right? Let's say we have 4 different options that we're considering for a corrective action. And then as a team, we talk about, okay, how effective is that corrective action going to be? How much is it going to cost? And how quickly could we implement it? And we might use this approach to essentially determine or pick the optimal solution to address the problem. Now, there's one other step here that I think is incredibly important, and that's brainstorming unintended consequences associated with proposed changes. So when you're evaluating those possible solutions, don't just think about, hey, obviously, is this going to be effective or not? It's really important to also ask yourself, is this corrective action going to have some sort of unintended consequence somewhere else in our value stream? Because that needs to be factored into the decision. The other really important element here of problem correction is dispositioning that affected material. Once you identify the root cause and you know the scope of the problem, it's time to take your risk assessment and disposition that affected material. Maybe it's scrap, maybe it's used as is, maybe it's somewhere in the middle, maybe it's a rework or a reprocessing, but now is the time in the process to disposition the affected material. And then the next step is what we call recurrence control. So let's say you have evaluated potential solutions and you've picked a handful that you truly believe in. Now it's time to make those corrective actions a permanent part of your quality system. And this might include updating your control plans, your flow charts, your PFMEAs. There's all sorts of different documents and standards within our quality system that should be updated to reflect this new element of control that we have. The other important element here that often gets overlooked is training. So if we're implementing some sort of new control or inspection or new step in the process, it's really important that we train all of the affected stakeholders, the employees, the people who work the process, to make sure that they understand it and that they know how to do it properly, because that's how we're going to make it effective, right? The other tools that are really important here during recurrence control might be something like a tree diagram. So oftentimes when we're implementing corrective actions, it's not just a single corrective action. It's often 2, 3, 4, 5, 6 different corrective actions. And oftentimes they have different timelines, they have different owners, they have different milestones. And so oftentimes what you can do here as you're planning out your corrective actions is put together, let's say, a really simple tree diagram here that has all of the different elements of your entire corrective action, and make sure you've got clear ownership and milestones associated with all those activities. Now, the other thing you can do once you have a tree diagram is do a little process decision program chart analysis to uncover potential obstacles or challenges or any sort of uncertainty in your corrective action plan, and brainstorm any sort of, countermeasures or contingencies to make sure that those corrective actions are implemented effectively and that they're implemented on time. By the way, we can't talk about recurrence control without talking about SPC. Control charts are a fantastic way to essentially monitor and control different aspects or different, process parameters or quality attributes associated with your process to make sure that you're only experiencing normal cause variation. And if there is any special cause variation in the future, any new sources of variation that crop up, that your control chart detects it and alerts you to the problem, and then allows you to kind of go through that root cause analysis process one more time. And then last but not least, right after we've implemented all of our corrective actions, it's time to verify the effectiveness of those corrective actions. And essentially what this means is monitoring your process and monitoring that change to make sure that you've effectively reduced or eliminated the root cause. Now, in some circumstances, you're not going to fully eliminate a root cause or a defect. And so it's really important here. This is a common mistake I see people make. Use a detailed verification plan. And what do I mean? So if in 6 months you think you can reduce customer complaints by 30% or 40% or 50%, you should be clear about that when you create your verification plan, because essentially that's the standard that you're going to hold yourself accountable to at the end of the day and at the end of the process. You're going to say, hey, was I able to effectively reduce complaints by 30%? If you leave it vague, if you just say, hey, reduce customer complaints or eliminate customer complaints, at the end of the day, somebody might look at that and go, hey, your verification failed. You did not eliminate all of your customer complaints, when in reality, you did implement some corrective actions that were incredibly effective. So make sure you're specific and clear about your verification plan. You can use SMART goals here, right? Specific, measurable, attainable, realistic, and time-based goals when setting up your verification plan. By the way, this can go one of two ways. So if the data indicates that the corrective actions were effective, well then celebrate, right? You just did your job and you did a great job. If the data indicates that the corrective actions were ineffective, it's time to bring that team together to go through the process again. So generally one of two things happened, right? Either you didn't identify the true root cause, or the corrective actions that you picked were simply ineffective in addressing the root cause. So if you fail your effectiveness check, go back and look at both the root cause that you came to and the corrective actions that you chose to determine whether it's, hey, we missed the root cause, or did we pick the wrong corrective actions. Okay, so that's it for sort of the root cause corrective action, process. Now let's talk about preventive action, because this is a big part of CAPA, right? It's corrective action, preventive action. And so I love this quote from Benjamin Franklin, who said, "An ounce of prevention is worth a pound of cure." And this is a really important part of our quality system. If you identify some effective corrective action in one element of your business or for one particular process that you have, it's really important to apply those same lessons learned or those same corrective actions to other similar processes so that everyone essentially benefits from the work that you did and that you prevent a failure from ever occurring in the first place on that similar process. That's a really important part of the CAPA mentality. Don't forget it. Don't forget to think about preventive action. All right, that's it for today. I know that was kind of a long one. Remember, we went through problem identification, root cause analysis, problem correction, recurrence control, verification, and prevention. Hey, if you really like this, hit that like button so that other people just like you can find this. And if you really, really loved it and you want to stay on that journey to become a CQE, hit that subscribe button so that as I publish new material just like this, you get notified. You can stay on this journey to become a CQE. And if you love this, really, really love this stuff, and you want to learn more about becoming a CQE, head over to cqeacademy.com, because I've got a ton of free stuff, exam day guides, practice exams, study plans, and all sorts of other fantastic resources that you can get for free. Head over to cqeacademy.com and sign up and get a bunch of free stuff. All right, have a great day. Bye.